Hi, everyone. Welcome to Chapter 2, Organizing and Presenting Data. So in this video, we're going to do a little bit of an intro and we'll talk about the different types of data, and then we'll do an example where we have to identify the different types of data. So in this chapter, we're going to be going over graphs, which a lot of you I know are familiar with graphs, and in statistics, they're commonly used to organize, summarize, and analyze collections of data. And it's just a nice way to visually present our data. And a lot of times it's easier to understand and comprehend our data rather than looking at, a set of data in an Excel spreadsheet. A lot of times it's nice to, systematically organize data and display it in a nice graph. Now, we've talked about the word data. Raw data is data before it has been arranged in a useful manner or analyzed using any statistical techniques. So when I speak of data, a lot of times we're assuming that it's raw data. So the data that we collect, from a sample or a population, and before we, arrange it into any useful graphs or analyze it using any numeric computations. So just think of raw data as data before it's been arranged in any useful manner. So section 2.2 is going to go over the different classifications of data. And before we get into the two types of data, let me just first talk about what a variable is. And a lot of you that have taken other math classes before are familiar with what a variable is. In statistics, a variable is a type of information, usually a property or a characteristic of a person or thing that's being measured or observed. So let me give you a couple of examples of what a variable could be. I mean, there's endless variables that we could, sit here and list together, but let's just think of some variables to list as examples. So an example of a variable could be height. So that's a property or a characteristic of a person or thing, right? So it's really anything that we're interested in measuring or observing. Weight. We can measure somebody's age. We can measure somebody's gender. Not necessarily, I guess measure I should use when we're talking about a numerical observation, but something like gender, which is not numeric, right? We could, I guess, consider that an observation. We could observe somebody's gender, somebody's religion, ethnicity, eye color, and so on and so forth. So these are just a handful of examples of what a variable could be: height, weight, age, gender, religion, ethnicity, eye color. So anything that we're measuring or observing from the group that we're studying. Now, a data set is a collection of several data pertaining to one or more variables. And we're going to be working with data sets throughout this whole, semester. So for right now, I just want to go through the difference between the two types of variables. So we have two types of variables. We have what's called categorical and numerical. So first, let's start with a categorical variable. So a categorical variable, let me highlight it and then we'll talk about it. So a categorical variable represents categories. It's non-numeric in nature. So before we list any examples here, let's go back up to the examples that I listed up here: height, weight, age, so on and so forth. And let's pick out the categorical variables. So the categorical variables would be gender. So let's just list some examples. So gender, religion, ethnicity, eye color, and we could even think of some more, right? Favorite color, we could do favorite soccer team. Now I'm running out of room, but those are just some examples to name a few, right? Of an example that would be categorical. So anything that when you collect it, it's not going to have a numeric value, right? Gender is not numeric, religion, non-numeric, your ethnicity, not numeric, eye color, non-numeric, right? So these are all examples of variables that would fall into certain categories. Now, the other type of variable is numeric or numerical. And I think that's what a lot of people are more familiar with, right? When they think of data, they always think of numbers, but not every variable now we could see, right, is numeric. It could be categorical. But a numerical variable is a variable where the value is a number that results from a measurement process. So let's list some examples of numeric variables. And we can even pull some of the ones that we listed up here, right? Height, weight, age, those are all numeric, right? If I ask your height, you're going to give me a number answer. If I ask you your weight, you're going to give me a number answer. If I ask you how old you are, you're going to give me a number. Some other examples could be the number of pets you own, right? If I say how many pets do you have, you could say 0, 1, 2, 3, 4, so on and so forth. What if I asked you what your current GPA is in school, right? That's going to be numeric. And we'll do one more. So how about the number of goals scored in a soccer game? Right? So you could score 0 goals, 1 goal, 2 goals, 3 goals, so on and so forth. So these would be all examples of numeric variables. So now that we see the difference between categorical variables and numeric variables, let's move on now because we can further classify numerical data. So numerical, and this is only for numerical data. We can't further classify categorical. If a data value is categorical, or a variable is categorical, I should say, that's it. It's categorical. However, if a variable is numeric, we can further classify it as either being continuous or discrete. So let's go through the difference between the two. So let's start with continuous. So continuous data are numerical measurements that can assume any value between two numbers. And discrete data are numerical values that can assume only a limited number of values. Now, what does this mean? So let's move over to the whiteboard and I'll give you an example. Let's start with continuous. So let's start with an example of a continuous variable. So weight is an example of a continuous variable. Weight is numeric, right? But it also happens to be continuous. Now, here's the reason. Let's imagine a number line. Let's say this is a number line and it's weight. So let's say this is in pounds, and let's say we have 140 pounds, 141 pounds, 142 pounds, 143 pounds, and so on and so forth. So most of the time when we get on a scale, right, we use a digital scale. And a lot of times the number either rounds to the nearest half a pound or the nearest tenth of a pound. So for example, you might get on the scale and it might say 142.2 or 142.7, right? So it usually goes at one decimal place. But if you think about it, you can really weigh more than 142.2, right? What if you weighed 142.24739 pounds, right? So it is possible that you can weigh something in between, let's say 141 and 142 pounds. So now the question becomes, well, how many weights are there between 141 and 142 pounds? Even though our scale a lot of times goes to nearest tenth, we could still go further than that, right? It's just that's as far as our scale is going to go because we don't really need to get that precise. But it is possible to weigh 141.2104763 pounds, for example, right? Look at how many decimal places I went out. So how many numbers are there between 141 and 142? Well, there's an infinite, right? Because really the next number after 141 is 141.0000001, right? Somewhere out in space. And then 141.000, a whole bunch of zeros, right? Then a 2, and so on and so forth. So technically, we really can't count from 141 to 142. Therefore, there's an infinite amount of weights, right, that we could possibly assume. So that's why the definition for a continuous variable, and let me go back to your worksheet for a minute. Let's just go back and look at the definition. Continuous data are numerical measurements that can assume any value between two numbers, right? So what I did here was I picked two numbers on the number line, 141 and 42, and I'm showing you that it is possible to weigh between 141 and 142, and we could weigh anything between 141 and 142, and there's an infinite amount of numbers between 141 and 142, so that's why we say that weight is continuous. Same for, I just happened to pick 141 and 142. You could have picked 146 and 147, right? There's also an infinite amount of weights that a person could assume between 146 and 147. So weight is continuous. Another example of, and I'll list this, so let's go back to the worksheet. And so an example of a continuous data value could be weight, height. Age is also continuous, right? Because you could say you're 20 years old, but you're not exactly 20 years old. You're 20 years old for an entire year, right? But as the days go by, or even the minutes and the seconds, you're getting older. So even though we say we're 20, we're continuously getting older by the second or the millisecond. So we can't really count our age, right? Because it's continuously getting older. Same thing with time. So weight, height, age, those are examples of continuous data. And continuous data tend to be measurements. So any sort of measurement is most likely going to be continuous. So now let's talk about discrete. So discrete data are also numerical values, but they can assume only a limited number of values. So let me give you an example. So let's say the number of people in a family. So again, let's make a number line, right? For number of people that could be in a family. Now, you can't have a negative amount of people, right? There could be 0 people in a family, 1, 2, 3, 4, 5, 6, 7, and so on and so forth. So pick any two numbers, let's say 2 and 3, like I did before with the weights. Can there be any amount of people between 2 and 3 in a family? And in this case, no, right? Because we're talking people. People are countable. So there could only be a limited number of people in a family, 0, 1, 2, 3, 4, 5, and so on and so forth. So since the number of people in a family can't assume any number between any two numbers on a number line, let's say 2 and 3, we consider it discrete. So this would be an example, the number of people in a family, of a discrete random variable. And I'll give you some other examples. So another example of a discrete variable would be number of runs scored at a baseball game. So think if a variable, if the value of the variable could be countable, most likely it's going to be discrete. Like we could count the number of runs scored at a baseball game, right? It's 0, 1, 2, 3, 4, so on and so forth. Another example would be the number of books on a shelf, right? You could count the number of books on a shelf. They're countable. So that's how I want you to think of a discrete variable. So now that we see the difference between, continuous versus discrete data, let's do an example. So example 1, there's 11 different variables that I gave you, and we have to identify if the variable is categorical or numerical. And if it is numerical, then let's further classify it as being either discrete or continuous. So some of these I already talked about when I was listing examples above, but that's okay. We'll do it again. So let's look at the first one. So the first one is a person's height. So height is numeric, right? But is it discrete or continuous? So remember what I said before, anything that's a measurement, height, weight, age, that's going to be continuous. Let's look at number 2, an individual's political affiliation, meaning are you a Democrat? Are you an independent, a Republican? So that's non-numeric, right? So this is going to be categorical. And remember what I said before, for categorical data, you can't further classify it. It's just categorical and that's it. So let's look at number 3. The number of times per day an individual updates their status on Facebook. So a lot of times you could kind of be tipped off too as whether the variable is going to be categorical or numeric by when it says the number of. A lot of times when you see the number of, that's an indication it's going to be numeric. So the number of times we update our status on Facebook, so that's going to be numeric because we're counting how many times. But is it discrete or continuous? So this is going to be discrete because we could count the number of times per day that we update our status on Facebook. We could do it 0 times, 1 time, 2 times, 3 times, so on and so forth. So this is going to be discrete. Number 4, the number of gallons of fuel used to travel from New York to Chicago. So again, number is going to be numeric. Now, is this going to be discrete or continuous? Now, since we're talking about the number of gallons of fuel used, whether it's, a plane or a car to travel from New York to Chicago, we're measuring the number of gallons. So remember, measurements are going to be continuous because we can't count the number of gallons. It's not like we would use 300 gallons or 301 gallons or 302. There's the amount of gallons could be between 300 and 301 gallons, right? And then how many values are there between 300 and 301, right? There's an infinite amount. So we say it's continuous. A person's hair color, since we're talking about color, this is going to be categorical. Number 6, an opinion to the question, is the President of the United States doing a good job? So this is a question that requires a yes, no, maybe, I don't know answer. It's not numeric. So this is going to be categorical as well. Shoe size. So when you go to the store and buy a pair of shoes, right? They come, and let's talk US shoe sizes because it's different in Europe and different countries. So shoe size is going to be numeric. Now let's think, is it going to be discrete or continuous? Can we count shoe sizes? So the way it works here in the US, right, we have half sizes. So you could be a size 2 or a 2.5 or a 3, 3.5, 4, 4.5, and so on and so forth, right? There's no other sizes in between. Shoes only come in half sizes, and that's countable. Therefore, shoe size is going to be discrete. The number of inches of snowfall per year on Long Island, so that's going to be numerical. And this is going to be continuous since we're talking about a measurement, right? If we had to count the number of inches of snow that we get in a year on Long Island. So since it's a measurement, we say continuous. The number of followers an individual has on Twitter. So number, right, means numerical. And since we're talking followers or people, they're countable, right? You could have no followers, 1 follower, 2, 3, 4, 5, right? But we could count the number of followers. So that's going to be discrete. Number 10, the amount of soda in a 2-liter bottle. So this is going to be numeric. And I know the bottle says 2 liters, but what I mean is if we were to actually pour it out and measure exactly how much is in that bottle, a lot of times, whether it's a bag of chips or a bottle of soda, there's not exactly the amount that it says on the bottle. So not every bottle is going to have exactly 2 liters. It could be a little underfilled or a little overfilled, right? There could be 1.999999999 liters in that bottle, or 2.01 liters in the bottle. So it could be a little underfilled, a little over. But since we're measuring, it's a measurement process, right? How much soda in terms of liters is going to be in the bottle, it's going to be continuous. And then last, number 11, a student's credit load for the semester, meaning how many credits are you taking? So that's going to be numeric or numerical. Now, a student can take no credits. We do have half credits. A lot of colleges have half credits, right? So typically they're either going to be whole credits or half credits. So you could take a half a credit, you could take 1 whole credit, 1.5 credits, 2, 2.5, but they are countable. You can count the number of credits that you're taking for the semester. Therefore, credit load's going to be discrete. Now we'll stop here, and then in the next video, we'll start looking at how to display our data in terms of graphs, and we'll start with a stem and leaf graph in our next video.